So what energy can I use? Kinetic. So it has chemical potential. Me eating it will convert that to kinetic when I start using that energy, right? So that was kind of this one thing I wanted to review with you. All right. So we're talking about gases now specifically because that's easier to relate everything we just talked about. So I don't know if we did this yesterday, but we can just title the next unit here, gases. What do we know about gases? Let's list all the things we know. We don't need to write them all down. Do gases fill their container?
Yes.
Yes. Do they have definite shape? No. Do they have definite volume? No. If they fill their container, let's say this was filled up with some special gas. I said that yesterday and everyone laughed. I don't know why. Why is that funny? But has special gas in here. I open it up. What happens to that special gas? Goes from high concentration to low. There's none of it in the room, right? It's just air. So what would the gas try and do in this room? Spread out. You have to try and fill this room. So volume is not definite. So one thing that we should write down, gases always expand. That's important to remember. They're always trying to expand. What's an ideal gas? This is a good time to talk about ideal gas. Morgan Eve, what's an ideal? Read your definition, please. Okay, I'll say what she said again out loud, a little bit louder, and see if it makes sense to anybody. Theoretical gas, right? What's theoretical mean? That doesn't necessarily exist, right? So theoretical gas, where the particles are negligible, right? Negligible, that's the word. Negligible. Particles are negligible, and they have no attractive forces. No interactions. Yeah. Okay. All right. So what the heck does the word negligible mean? What? Neglect?
Neglect.
Kind of. What does neglect mean? Ignore. Pay no attention to. Yeah, okay. So an ideal gas are these fake gases. They don't exist. But every real gas, so like hydrogen, helium, and carbon dioxide, real gases try and behave like ideal. They want to become ideal. What's the word ideal mean? I'll get back to negligible in a second. What's ideal mean?
Just prime.
Prime. Like, do you have like an ideal job in your head that you want to do when you get older? What does that mean, ideal to you?
Something more.
It's something you want, right. Okay, so ideally I'd like to get paid, $10 million to teach. That'd be sweet. All right, that's not going to happen, but ideally that'd be nice. So ideally it's kind of like the goal, right? Or maybe like a dream or something you're trying to achieve, right? That's what ideal kind of means. So real gases always expand trying to reach that definition of ideal gases. Essentially what an ideal gas is if you have a sample of gas and it keeps expanding to the point where the individual gas particles are just by themselves. So imagine you guys are a gas. And I said, all right, show me how to act like an ideal gas. You would all get up, walk out of the school, and everybody would walk in a separate direction, and you would just keep walking for like hundreds of miles. So eventually you're just by yourself. You're not around any of your other particles. So you guys would not be a sample of gas anymore. You would just be on your own. That's what ideal gases are. They just exist. They don't exist, but it's a concept that this is why gases expand. They want to be by themselves. They don't want to be near each other. And why is that? Gases have really weak forces of attraction. Weak intermolecular forces of attraction. So gases don't want to be near each other. They want to spread out. They want to get away. They don't like each other. Ideal gases, they said the particles are negligible. What the heck does that mean? It means they don't matter. It doesn't count. Let me give you an analogy. Does the Earth have some sort of weight to it? Does the entire Earth have a weight, a mass? Yes, it does. If I took Mike Flower, threw him off the Earth, he lived on Mars, would the weight or mass of the Earth change because Mike left? No. Why? In fact, we could all go live on Mars. Me, all you guys. Would the weight of the Earth change? Would the mass of the Earth change? Why? No, it wouldn't. That's a joke. Is the Earth pretty big? Does it have a humongous mass? Yeah. Do you think the weight I am putting on this Earth right now, pushing down on the Earth, is affecting the weight of the Earth at all? No. Why? I'm too small compared to the size of the Earth. That's what negligible means. So when you have a whole sample of gas particles together, this one little particle, the mass of that thing, the volume of that thing, how much space that takes up, how much space I take up, is really negligible. It has nothing to do with the weight of the entire Earth or the mass of the Earth or how much space the Earth takes up. So that's what negligible means. So gas particles are similar, real gas are similar to ideal, where the individual particles really don't matter. That's called negligible. So we're going to talk more about ideal gases a little bit later. But the concept here, these are the two main things. Gases always expand, and they have very weak forces, and that's why they always expand. They want to get away from each other. All right, hopefully that makes some sense. And again, we'll talk more about ideal later. So there's three things that really, three things that affect gases. Oh, by the way, if you guys were going to guess which two gases on the chart are most like ideal, would you have an educated guess for me? Which two gases on the chart do you think would be most like ideal? Just very easy to expand to the point where they don't really exist anymore. Hydrogen and helium, right. They're the two lightest elements, and not just the mass, but their densities are the two lowest. So they just basically expand, expand, expand. So we'll talk more down the road about that. But three things that affect gases. All right, what can we do to gases we can't do to liquids and solids? Compress and expand. That's called pressure. That's called pressure. You can put pressure on gases. You can't do it to liquids and solids. It doesn't really do anything. Pressure affects gases. What else can we do to a gas that can maybe help it expand? So we can put a lot of pressure on a gas, make it kind of take up hardly any space. We can release that pressure and let it take up more space. Or we could do this to it to help it expand. What can you do to a gas to help it expand? Besides releasing pressure? Heat it. Temperature. And now the last one is affected by temperature and pressure. So if you put a lot of pressure on a gas, it takes up hardly any space. If you release the pressure, it takes up a lot of space. What's that definition? What am I defining? It takes up space. What's that word? The amount of space something takes up. Volume. So pressure, temperature, and volume are all related when we're talking about gases. PTV. PTV is kind of just how I'll abbreviate it. PTV. Okay? So with gases, all three of those play a role. All right? Now, what we need to learn real quick before we get out of here is the relationship between those three. But I want to show you this demo first. So let's come on back.